All right. Now, here's what we're going to do. Now, this isn't really actually an exercise that you're going to do, but it's going to help you do what you're going to do in just a minute. Okay? We're going to take all these expressions here and figure out, well, what would they equal? Okay? So let's start off with this first one. Now, here's the idea. What I want to do is I want to take one of those three Pythagorean identities and just manipulate it. And so when I say manipulate it, I mean like take something to one side or swap two things. Okay, do something like that. So for 1 minus cosine squared, all right, that would obviously use the first one up there with it. Okay, so how can I make that one say 1 minus cosine squared? Subtract cosine squared, right? You take like cosine squared and you'd move it over there, and it would make it say 1 minus cosine squared with it. Okay, and so you would get 1 minus cosine squared. Now what would be left on the left side? Sine squared. So 1 minus cosine squared is sine squared. Okay, see how I manipulated the identity to figure that out? Okay, all right, now let's look at the next one. All right, cosecant minus cotangent. Now, which one am I sort of manipulating there? The bottom one or the last one? All right, so how could I make it say, how could I make this say over here, I can't say it, cosecant minus cotangent. Right, subtract the cotangent over. Okay, so it would be 1. All right, talk to me. Y'all see what I'm doing there? Is if you're not a very visual person, it's hard to see. Okay, but, all right, do I need to explain this one? Yes. Okay. All right. So we're doing this one. This is what's happening. We're taking the cotangent squared and subtracting over there. Because what we want is we want to make it say cosecant squared minus cotangent squared. Okay? So if I brought that over, we get cosecant squared minus cotangent squared. Now, what would be left over on the left side? 1. Okay? See how we're just rearranging the furniture. That's all we're doing. Okay? Just, don't do that to a blind person. That's kind of me. All right. Secant squared minus 1. Let me move my. So, I always keep these in front of me like that so I can look at them. Okay? So let's see. How could we make something say, oh, I forgot secant. Poor secant. Just left him behind. Remember algebra honors like Uncle Wes? Yeah, you ever left him at Johnny's? All right. Now, here we go. So how could we make something say secant squared minus 1? Subtract the 1 over. All right. And so what would that leave me with? Tangent squared. There you go. Now getting it better now? And a lot of times when you see the first couple, you start doing this a lot, you get better. All right, 1 minus cosecant. Now this one's a little different. So to get 1 minus cosecant right there, right, you take this one over, but then you would have to take the cotangent and swap it over. So it would be negative cotangent squared. So basically what you're doing there, yeah, you're moving stuff around, but you're basically swapping them, aren't you? And when I swap it over, it's going to change the sign, isn't it? Okay? Right, right. It's like we're subtracting both of them from both sides. So we can just get to the point where we just have 1 minus cosecant squared. Let me bring them down here. Come on, secant squared. All right, here we go. All right, this one's pretty easy. Cosine squared minus 1. Well, not that easy. What that one? Negative sine squared. Okay. All right, talk to me. Do I need to explain that one a little better? Okay. All right, tangent squared. Let's do the last one. Tangent squared minus secant squared. Yeah, negative 1. Okay. All right. Now, you got the idea of how to manipulate a Pythagorean identity. Okay, rearrange the furniture so you can get what you want it to say. Now, let's look at some examples here. And let's go to your sheet here. And let me give you some tips here to how do I know I'm going to use Pythagorean identity. Okay, because this is the second strategy, and overall you're going to have like 3 to 4 strategies to look at. And so you're going to have to realize, well, what strategy do I need to use? Okay, when it comes to changing everything to sine and cosine, what really tips you off there, like on the problems that you did last night, was all the multiplication. Because when I'm multiplying stuff, I can do what to maybe simplify stuff? Cancel. You cancel stuff out. Okay? Now, here's the idea on your Pythagorean identities. And you maybe want to write this at the top of your worksheet. Okay? I'm going to use Pythagorean identities when I see, let me actually write it down for you. Okay? When I see 2 trig functions and they're both squared. Okay, because that's a theme, isn't it? Every Pythagorean identity has 2 trig functions in it, and they're both squared. Okay, the other thing would be if you saw a trig function squared and a plus or a minus 1 in there somewhere. Okay, so I see 2 trig functions squared, and then I see a trig function squared and a plus or minus 1 somewhere. That's what I'm going to look for to substitute something with a Pythagorean identity. Now, let's notice on this one that really I can't, there's not a Pythagorean identity there yet. What's missing? The squares, okay? So, if maybe one of those signs that I had was squared, it'd work out. So, what do you think we can do here? Yeah, FOIL it out. Now, we really don't have to FOIL it because they're conjugates, okay? So, we can just do first and last because they're conjugates. So, and think about what's going to happen when you multiply the sine times the sine. There goes your square right there. Okay. Now, so first, that's going to give us 1. And now last, and when you always multiply conjugates, you always get minus. Okay. And so it'll be minus sine squared, right? Now, I need this. Hang on. I should have done this earlier. I need to look at this. Okay. So how can I get a 1 minus sine squared? That's cosine squared, isn't it? Okay. Now y'all see how it's kind of, a pretty good idea to always have these looking at you in front of you. Okay. So I'll paste that on every problem that I do here. That's it. All right. Yeah, it does. Hang on. All right. Okay. Now, a lot of times when you see like parentheses, I know my knee-jerk reaction is to distribute. Okay, it may or may not be yours, but that's kind of my reaction. But that's kind of counterintuitive right here. What you should kind of realize here is, hey, I've got a square one in there, and I've got a 1. So that's probably some sort of Pythagorean identity. Okay, so which Pythagorean identity could we maybe manipulate here? The second one. Okay, how could we make that second Pythagorean identity say secant squared minus 1? This should be squared. Mm-hmm. Just take the 1 and subtract it off of both sides. Okay. Like that. Okay, so secant squared minus 1 would just be really tangent squared. So we get cosine squared times tangent squared. Talk to me. Did you not follow that? All right, watch. This is where you just got to be visual. All right, how can we make it say secant squared minus 1? We just take this 1 over and subtract it. Okay? No. Because see, the thing is, the cosine, it didn't have a 1 to go with it. Okay? Now, from here, you've got two of them squared, but cosine squared and tangent squared don't go together, do they? They're not in the same Pythagorean identity, so we're going to switch back to our old stuff because this is multiplying. What's a good strategy to use there? Right, change everything to sine and cosine. So we can change tangent squared to sine squared over cosine squared. Now you see how that's going to work out very nicely there? Right, they're going to cancel out, and so this would just be sine squared. Secant squared minus 1 is tangent squared. Go back to this, Thomas. See, if I take that 1 over, I get tangent squared x equals secant squared x minus 1. All right, we okay now? Yeah, didn't I tell you this will be a little bit more challenging? Okay. But once you start figuring out how to manipulate those Pythagorean identities, it's not that bad. All right, let's look at this one. Now, we're missing something here. Got my 1, don't have any squares. All right, but notice this. What are all three of these doing right there? Multiplying. So let's change stuff to sine and cosine. Okay, so let's see. Cotangent is cosine x over sine x. So sine x cancels. Right. Okay, so we got 1 minus cosine squared. Now, there's our identity, right? Okay, so let's see. How can we manipulate that first one to say 1 minus cosine squared? Subtract cosine squared over, and then that would leave me with sine squared. Okay, that one wasn't too bad. All right, so number 7. Let me paste here. Now here again, you know, it may be tempting to try to distribute. All right, but let's see if we can use a Pythagorean identity. Right, now this one's just looking at you right there. Okay. Now, does it matter that it's backwards? Because if you're adding, the order doesn't matter. Okay, so cotangent squared plus 1 is just cosecant squared. Okay, so we get sine squared times cosecant squared. Now, since it's multiplication, just change everything to sine and cosine. So I can write cosecant as 1 over sine squared, and they cancel. It's just 1. A lot of times you get an answer, it's just 1. A lot of these it happens. That's a quotient, reciprocal identity. Okay. So remember cosecant we can write as 1 over sine. Secant is what? Right. Okay, so you use your quotient identities and your reciprocal identities to write everything as sine and cosine. Yes. Which one? Your Pythagorean identities? Yeah. But remember, you only have to memorize the first one. You know the first one, you derive the second and third one. Okay. All right. Now let's see on this one. Hang on, let me paste it. All right, now again, instead of multiplying, you got a 1 and an assigned squared. So let's see how we can manipulate that. Not quite. Think about it. How can we get a 1? We just take this one out. Right, so just cosine squared. Okay, so 1 minus sine squared, forgot my variable on that one, is cosine squared. Okay, now what can we do? Right, so we'll change this to 1 over sine squared times cosine. Now nothing's going to cancel this time. So that would give me cosine squared over sine squared, but that's cotangent. I love these problems, by the way, because it's not just straight simplifying. It's like a puzzle. It's like you got to put the pieces of a puzzle together. Math teacher. That's always the answer to that question. Now, anything you have to take calculus or anything, you have to know all this stuff in calculus. Do what now? No, it wouldn't. But the thing is, but here's the bottom line. You could put the calculus version of this in a real life problem. And so you would have to know this to know the calculus to do the. There's a lot of calculus applications for it. Okay, so calculus has real life applications, and you need all this stuff if you're going to have calculus. Okay. All right, let's try this one. This one's pretty easy. All right, so how can we get a cosecant squared minus a cotangent squared? Oh, dang, I left the answer on it. That's just one. Yeah. So that was pretty easy, wasn't it? All right, show this. 4 square. All right, here we go. Now, this one's pretty simple too. How can we get cotangent squared minus cosecant squared? All right, subtract this over, but then you're going to have to subtract the 1 over. So that's going to be -1. Okay. All right, for this one. All right, now, again, I'm probably stay away from multiplying it out. Secant squared minus 1 is tangent squared. Okay, so we'll get cosine squared x times tangent squared x. Now what then? Right. We can write tangent is sine squared over cosine squared. And that works out pretty good. Yeah, it's just sine squared. Yeah, just a sec. Okay. There you go. All right. Now, shh, yeah, look up. Stop talking. All right, on this one, you've got a tangent squared, but you don't have another trig function squared, and you don't have a 1 there either. Okay. I don't know. What do we do? Well, look at this. That's being multiplied to, well, I wouldn't change this one yet. Right? So if we change secant to 1 over cosine, there's my 1. There's your 1 right there. Yeah, because you're multiplying. Okay, so they cancel. So 1 plus tangent squared is secant squared. All right, now this one, no squares, no ones. I think this one doesn't use any of them. Okay, but let's see what we can do. So if we don't see any Pythagorean identities, we see multiplication. We'll change everything to sine and cosine. Now, the division thing, remember we can always change division into multiplying by the reciprocal. Okay, so we'll use that. Now, cotangent is cosine over sine, all right? And then secant is 1 over cosine. We've got all this over sine. Okay, now, before we start maybe multiplying by the reciprocal of that sine right there, cancel, yeah, okay. So it gives you 1 over sine over sine. Now, so we'll multiply by the reciprocal. Now, what's the reciprocal of sine would be 1 over sine. Right, that's it. All right, the idea when you have a complex fraction, listen to me because that's a really good question because we were doing a lot of canceling when we would do tangents on our half angles and double angles. If I look at like the top fraction versus the bottom fraction, what you do in a complex fraction is if you cancel the denominator of a complex fraction, then you have to cancel the denominator of the bottom part. Okay, so for instance, let's say I have like a really easy fraction, like 3/5 over 4/5. Those fives can cancel because they're both denominators. Okay, but now if I have this, can those fives cancel then? No. Okay, so they got to be, it's like, normally when we cancel, we say we cancel a numerator with a denominator, but when it's a complex fraction, it has to be numerator with numerator, denominator with denominator. Okay, all right, so that's why they didn't cancel there. Now we can take one more extra step there. Right, that's cosecant squared. Oh, look, that was on. Sorry about that. All right, now you can take your sheet there. Let me put the answers up for you. Now you've got the even ones to do now. Okay. Now there's a couple. Did I leave off 21? Oh yeah, we need to do 21. All right, I'm sorry. All right, there's a couple I'm gonna tell you not to do. I'll tell you in just a minute. Okay. All right, let me do 21 with you on the document camera since I left it off. Now, it took second period a while, but they figured it out. I'm going to see if you guys can figure it out quicker. So it's pretty challenging here. No. Okay. All right. And they thought of the same thing. All right. So listen, we can't say that these are just going to go away. The reason why is because we would have to multiply before we subtract. Okay. So that doesn't work. All right. So see if you guys can think of something else, something better. No ideas? All right. Look at this on the board. All right, well, now the problem with, dividing is there's no equal sign. Okay, let me show. Oh, that's upside down when I show it that way. Well, that's not going to help, though. No, it can simplify. All right, let me show you this. Okay. Notice there's two terms. Both terms have a cosine squared. No, we've already said we can't do that because you have to multiply before you subtract. All right, look right here. No, because you don't have both sides. It's an expression, it's not an equation. All right, both of these on the board here have, no. Now, Thomas, you said distribute. It's something like that. It's, no. All right. I guess I'm going to have to tell you, second hour figured it out. You ought to feel ashamed. All right. Here's the idea. You said factor? Okay. How though? So you have a common factor of a cosine squared. So you bring one of them out. Okay. So if I factor out a cosine squared, okay. So let's think. Cosine squared times what would give me this back? Times sine squared. Okay. Cosine squared times sine squared would be sine squared times cosine squared. Now, minus. Now, cosine squared times what? 1. All right, now you see your Pythagorean identity there. Okay. Sine squared minus 1. Think about this. You know that what? Sine squared x plus cosine squared x equals 1. So to get sine squared minus 1, you just swap these two. So it's negative cosine squared. So you get cosine squared theta times negative cosine squared theta. Now, y'all talk to me. Did y'all see where I got negative cosine squared from? How I got that? Okay. Now, let's multiply this out. So cosine squared times negative cosine squared would be negative cosine to the 4th. And by the way, with 2 and 2, you really could mess this up. But are we adding the 2's or multiplying the 2's to get the 4th? Add them, right? Okay. All right. Now, when you raise a power to a power is when you multiply. Okay. And so when I just multiply like bases, you add the exponents. Now, this one, draw yourself an arrow on your sheet. This one, 21, is like number 20. Okay? So draw yourself an arrow from 20 to 21. That'll help you remember to look back at 21 when you try to work out number 20. Okay? Now, it's the factor. So like on number 20, you could factor out cotangent squared. And so when you do that, you'll have a Pythagorean identity to look at and do. Now, the ones that you can kind of leave off here, don't scratch them out because we're going to do them tomorrow. All right, but you don't have to do number 8 and number 22 yet. Okay, so we're going to do them. You just don't have to do them tonight. No, it's just those two. All right, let me put the answers up. All right, y'all start them here. Okay. And let's get as many as we can. We got like 10 minutes. I'm trying to put the answers up for you. Who's got? All right.